Okay, on number one, major question that I had on number one was they threw a new variable in there at you. That's just like a theta or an x. You can use whatever variable you want. When I was working it out, I just changed that funny looking b to a theta. It's just a different variable that they used. What you needed to have been able to have realized on number one was that was the cofunction identity. And we know that the sum of cofunctions add to 90. So that's how you would have attacked that. You would have had 2 theta plus 5 plus the other one, which is 3 theta minus 15 is equal to 90. So your thetas 2 and 3 were 5, and then 5 and negative 15 is negative 10. So you just had a 2-step middle school equation to solve there for your angle.
Is that,
go ahead.
30 or 3?
3 theta. Why did we set it equal to 90? Because cofunction of sine plus cosine equals 90. We copied that down one day. Add your 10, that gets you 5 theta is 100. So when you divide by 5, theta would be 20. Okay. On number 2, the twist that they gave you on number 2 was that it says theta divided by 2. It doesn't just say theta. If it just said theta, you would be looking at the interval between 90 and 180, the interval that they gave you. But it tells us that it wants to half that. So when you half that, that's 45 and 90. So if you think about where you are, if you're between 45 and 90, here's 90, here's about 45. So you're somewhere up in that little area of quadrant 1. Okay? It says, what is cosine there, positive or negative? Well, to get there, you would go right and up, so everything's positive. That's cosine sine, so your cosine's positive. The trick on that one was it said theta divided by 2, so you had to have halved that. Alright, number 3. First thing I did on number 3 was I found the positive angle that would go with negative 855. Didn't necessarily have to, but it just makes it easier to work with for me, and it's on the unit circle. So I took that negative 855, and remember you can go coterminal. You could, add 360 to it as many times as you want to. So I just hit negative 855 plus 360 enter, plus 360 enter, plus 360 enter until I got a positive, and it ended up being 225. So now I'm looking for the secant of 225. And the reason that was good is because 225 is in the unit circle. I used my unit circle a lot when I took this. So I went to 225 on the unit circle, found the ordered pair, negative square root of 2 over 2. Well, that's your cosine, comma, sine in that ordered pair. I need secant. Secant is the reciprocal of cosine. So I'll just flip that, make it negative 2 over the square root of 2. Then you can't leave a radical on bottom, so I'll multiply the top and bottom by the square root of 2. So it's negative 2 square root of 2 over 2. 2's cancel, negative square root of 2. Okay, number 4, you ready? Go too fast, you'll tell me I need to slow down some. Cosecant of 24 degrees in 20 minutes. Tells you to use your calculator, that's nice, but then cosecant's not on your calculator. So you got to remember that cosecant is the reciprocal of sine. So you're going to enter this as 1 over the sine of 24 degrees and 20 minutes. So that comes just making sure you remember how to get your degrees and minutes in the calculator. And thing that's not nice, if you look at those choices, all 4 of those choices look a whole lot alike. Anybody got what they think's the answer on that? It is B. Yes, ma'am, Grace Taylor. Okay, what about 5? We need to look at it or no?
Yes, please.
Alright. 5, they told me, looking down there underneath the triangle, that angle B is 73 degrees, 45 minutes. So angle C is a 90. So I can get the other angle because I know what a triangle adds to. So I can say 180 minus C, which is 90, minus B, which is 73.45. I can type all that in my calculator, and that told me that angle A is 16 degrees and 15 minutes. Now, unfortunately, that didn't let me eliminate any choices. All 4 choices had that for angle A, so that had to be the right answer for angle A. Now I've got to, they told me side B, if you look at the little triangle they drew you real quick, they told me side B here was 9, so I've still got to find the hypotenuse in side A. So I'll do the hypotenuse first. Looking from the angle they gave me, which is this one up here, 9 is opposite and C is hypotenuse, so that is sine. So the sine of 73 degrees and 45 minutes equals opposite over hypotenuse. So set that up and go solve. That would give you 9 is equal to C times the sine of 73 degrees and 45 minutes. So you would divide by the sine of 73 degrees and 45 minutes. So 9 divided by the sine of 73 degrees and 45 minutes. Should get you side C is about 9.4. Does that sound right? Okay, that lets you eliminate choice C and D. So we know we're at A or B now. We got to find side A. Well, A is adjacent. Adjacent is cosine. So it's going to set up the exact same way, except here where we divided by sine of 73.45, now you're going to divide by cosine. So your other problem that you're solving would be 9 divided by the cosine of 73 degrees and 45 minutes. What did that end up getting me? Got it. 2.6. Does that sound right? So our final answer would have been B. Page 2. Number 6 is same type of problem. Find angle, so it gave me angle B, so I'll find angle A real quick. No, a triangle adds to 180, so 180 minus C is 90, minus B is 58.45. Got me angle A was 31.55. Which again, all 4 of them have that. Oh, it's because it's scrolled maybe. All 4 of them on number 6 have that right. So maybe I wrote something yet. That was weird. Alright, so pick if you want to find, they gave you side A, so they gave you the adjacent one this time. So let's find side C first, the hypotenuse. Adjacent and hypotenuse is cosine, so I got the cosine of 58.45 is equal to adjacent over hypotenuse. Now I like the way this one sets up better. No, it sets up the same. There's one later that sets up better. C times the cosine of 58.45 is equal to 677.5. So you're going to divide by the cosine of 58.45.
What is that? Is that a 677.5?
Yeah. Okay, that ended up getting us 1,294.8. So that could be either A or C. Got it narrowed down to A or C now. 1,294.8. Okay, so now we got to find side B. which would be opposite. So looking at the opposite and adjacent will be tangent. So let's scoot that up a little bit. Looking at the tangent of 58.45. Tangent, I am, 58.45 is equal to opposite over adjacent. So there, you'll end up doing the same thing you did here, except it'll be you're dividing by the tangent. So you'll do 677.5 divided by the tangent of 58.45. And I believe I got 11 over 3.4. Does that look right? 0.42 to the nearest hundred. Thank you, sir. So that would be C, as in California. All right, 7, I used my unit circle. I went and found 210 degrees. So looking at your unit circle, go find 210 degrees. You got the order pair negative square root of 3 over 2 and negative 1/2. Remembering cosine, sine. Okay, but number 7 asks for cosecant. So that means I got to take the reciprocal of one of those. Cosecant is the reciprocal of sine. So I flip negative 1/2 and I get negative 2 over 1. Okay, number 8, I'll use my unit circle again. It says find all values of theta if the cosine of theta is 1/2. Well, remember cosine comma sine, so I'm looking for my unit circle where cosine is positive 1/2. So I see it there in quadrant 1 at 60 degrees. You see that? 60 degrees has a cosine of 1/2. It can't be anything in quadrant 2, all those cosines are negative. It can't be anything in quadrant 3, all those cosines are negative. You go here to quadrant 4 and check out 300 degrees. Doesn't it have a cosine of 1/2? There you are. Alright, number 9, we had one like this on the first page. The secant of 66 degrees and 53 minutes. Says use your calculator. Secant's on our calculator, so it's the reciprocal of cosine. So you're going to do 1 over the cosine of 66 degrees and 53 minutes. What'd you get on that? C. C is correct, Mundo. Good job. Alright, on 10 and 11, and I think there's another one, yeah, down there on 13. 10, 11, and 13 all. I originally tried to make it harder than I needed to. The easy thing to do is to use your calculator on those. I originally tried to, use my unit circle and calculate them all out, and it was a lot easier just to do it on your calculator. So number 10, I would hit cosine of 120 plus cosine of 45 and get a decimal and write it down. Anybody got a decimal for me on that?
0.207.
0.207. Okay, then I got to see if that's equal to the cosine of 165. So I'm going to hit cosine of 165. Would you get a decimal on it? Negative 0.965. So true or false, those are equal. False. So I'm not too shabby on that. And I did 11 and 13 like that also. We'll look at those as well. See, a lot of people will say, well, that 120 plus 45 equals 165, so they've got to be equal. Well, not necessarily when you're dealing with trig stuff. All right, number 11 Just type it in like it says on the left when you do the sine of 120 plus 225. I wrote down negative 0.2588. Is that what y'all got?
Oh, wait. Okay.
2588?
Yeah.
Yeah.
Yeah. Yes.
Then on the other side, sine of 120 plus sine 225, I wrote 0.1589. Is that about what y'all got? Those are equal, true or false? False. Okay, number 12 I did on my unit circle. And this is what I was talking to Grace about on the bell ringer, not necessarily this type of problem, but you could, if you lost your unit circle or didn't remember how to use your unit circle, you could, like on number 12, just hit cosine 30, write that decimal down, and then go through the choices and see which one is the same decimal. So that would work, but this one's so easy just to copy off the unit circle because you go find 30 degrees. Cosine is the first ordered pair in it, the first coordinate in it, square root of 3 over 2. So number 12 would have to be D, square root of 3 over 2. Alright. 13, we're going to do just like we did 10 and 11, but it was hard for some people to read those multiplication signs. They asked me what was supposed to be between those. That says sine of, on the right side of the equal sign, it says sine of 225 times the cosine of 135. And then there's another times between the last two. Do you see those little miniature dots in there? So I got 0 for the left side. Does that sound okay to you? What'd you get on the right side? Are you not done yet? Zero again. So does 0 equal 0? True or false? T-roo, you're right. Okay, 14 is just a calculator problem. You don't even got to do a reciprocal or anything. 14, you're just going to type tangent of 76 degrees and 19 minutes. Be real careful because all those choices look a lot alike, so they're just rounding a little different or got a decimal moved or something. They got a guess for it that you did?
B.
B is right, Mr. Lambert. Good job. Page 3. This page is where I did more math than any of the rest of the tests. Number 15 and then on number 17. I did more math on those two than I did anywhere else. 15, I had a brain fart for a minute. I know that never happens to you. I draw a triangle because I needed one. I got one picked. Nope. It's a square. I need a square. I need a isosceles. We'll just use this. Alright, 15 says the length of the base of an isosceles triangle is 58.33 meters. Each base angle is 36.69. So there's a 36.69 degrees, and there's a 36.69 degrees. Well, I know a triangle's got to add to 180, so when I added those together and subtracted from 180, that gave me this angle was 106.2. Well, that's not a right angle. I don't have a right triangle. So I was stupid for a second, thought, well, I don't know how to do that because I don't know where my hypotenuse is, blah, 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 blah. But all I had to do, it finally dawned on me, was split that into two triangles. Okay, because now here is your 90-degree angle on those. Okay, when I did that, that took that 58.33 and it split it, didn't it? So both of these little sections, that was 29.165. Okay, it says find the length of each of the two sides of the equal triangle. So I got an adjacent. If I'm looking from this angle right here, I've got an adjacent and I need hypotenuse. That is cosine. So I would say the cosine of 36.69 is equal to adjacent, which is 29.165 over hypotenuse. So when you cross multiply on that, you got x times the cosine of 36.69 is equal to 29.165. So you're just dividing by the cosine of 36.69. And I think I got about 36.37 meters. Is that what y'all got? Good deal, Lucille. Y'all probably automatically, I don't know, what's that called, an altitude in geometry when you draw that line? That took me a minute to think about drawing that. Alright, number 16, another true-false one. So this one, it doesn't say equal though, it says less than. So I hit tangent of 65 on my calculator and I got 2.14. And it's supposed to be less than. I hit tangent of 10 and I got 0.17. That is false. Nothing to that. Alright, this 17 is the other one that I did most of the work on. The reason I had to do a lot more work on it is because I had to work with the triangle that I didn't need in order to get to the triangle I need. See, I actually technically have 3 triangles in that diagram. The one I need is the one on the right. That's what I'm trying to solve for, that X there on the right. So first thing I had to do, it says I couldn't just go there because I don't know any other sides. I don't know any other stuff on that one. So I had to use the left triangle, the 30, 60, 90 triangle, because it told me it had a side of 30. So I could use that to find this. So looking from this 30-degree angle up here, that's on the small triangle on the left, that's hypotenuse and adjacent. Adjacent and hypotenuse is cosine. So I said the cosine of 30 is equal to adjacent over hypotenuse. And this was an easy one to solve when you cross multiply. X would equal 30 times the cosine of 30, which ended up being 15 square roots of 3. So that piece in there, that height that I've highlighted, is 15 square roots of 3.
Never mind.
You have the decimal for it? Is that what you were going to say?
No.
Oh, okay. Well, never mind. Alright, now I can use that to find the X on the other triangle because that 15 square root of 3 is also on the other triangle. So looking from this 45 down here, that would be opposite and hypotenuse. So that is sine. So the sine of 45 is equal to opposite over hypotenuse. Now what I did on this, since the choices are all in square roots, I used my unit circle. I could have done like Grace was saying earlier and get decimals and then check my decimal equivalent. But I went to my unit circle and found 45 degrees and saw that the sine is square root of 2 over 2. So I said this would be the square root of 2 over 2 is equal to 15 square roots of 3 over x. Okay? So when you cross multiply on that, I got 2 times 15 square roots of 3, which is 30 square roots of 3, equals x times the square root of 2. So I just got to divide by the square root of 2. Yes, Grace?
Where did the 45 come from?
This angle right here off my picture.
Oh, okay, so we're not finding. I guess you don't know.
Right, we jump to the other.
What
So
is that say after equal sign?
x times the square root of 2. I got that from right there. Alright, so we're going to divide by the square root of 2. So I got 30 square root of 3 over the square root of 2. Now, the problem with that is you can't leave a square root on bottom. So we got to multiply top and bottom by the square root of 2. Square root of 3 times the square root of 2, that makes that 30 square roots of 6 all over 2. Because that's square root of 4, which is 2. Now you can reduce that. 30 over 2 reduces to 15. So 15 square roots of 6. Like I said, those two were the ones where I did most of my actual figuring on. So much more of it I just used the unit circle in the calculator. $18, we've already done a couple like it on 5 and 6, but we'll knock it out again real quick. They give us angle A. So to find angle B, I know I got an angle A and I got C is 90. So I'm going to do 180 minus 90 minus A, which is 1138. And that ended up getting me 78 degrees and 22 minutes. Now this one's a little bit nicer because you can eliminate two choices on that. On number 5 and 6, they all had the same angle, but this one, I know now it's got to be either C or D. They're the only ones that have angle B right. So it's either C or D. Okay? Side, the hypotenuse is 241, so I'm going to find side A first. So looking from 1138, that would be opposite. So that's sine. So the sine of 11 degrees and 38 minutes is equal to opposite, which is A, over hypotenuse. Drop that. A is equal to 241 times the sine of 11 degrees and 38 minutes. This is the one I was thinking about earlier. This one sets up easier because you don't even have to divide on it. It's just a multiplication problem straight across. That ends up being about 48.6. So A would be about 48.6. Looking at choice C and D, it's got to be C, right? So all right, on 19, it does that trick to you again. It says theta divided by 2. So notice that. Might want to circle that. Normally it tells you that you're looking in the interval from 180 to 270, but now they want you to half that, so that turns to 90 and 135. So if you think about where that is on your unit circle, there's your 90. 135 would be somewhere in there, so you're looking in that little section of quadrant 2. To get to that little section of quadrant 2, you would go left and then up. So your cosine will be negative and your sine would be positive. Number 19 asks for secant. Secant is the reciprocal of cosine, so it would be negative. Last page, last question. A little different take here for number 20. Find the equation of the line passing through the origin. New page, come on. Passing through the origin so that the cosine of the angle is in quadrant 1, so it's going to be something like that. It says the cosine of the angle between the line and quadrant 1 is 1/2. So that means it's going to be 1/2 something. So I went to my unit circle to find out what ordered pair is at 1/2, and it's square root of 3 over 2. Got that off my unit circle. Why is that important? That gives me an x and a y. If I'm trying to write an equation in slope-intercept form, I'm trying to go to y equals mx plus b. I got to have an x and a y to plug in that. I know my b is going to be 0 because I'm hitting it at the origin. It told me that. But I got to find the m. So I plug these things in for the y and the x to solve for m. So I would say square root of 3 over 2 equals m times my x. And I can put plus 0 on there, but I don't have to. So now my step to solve for m is being multiplied by 1/2, so I'm just going to divide by 1/2. What's dividing by 1/2 the same as multiplying by?
2.
2, very good. So I got 2 square roots of 3 over 2. The 2's cancel out, so my m is square root of 3. So take square root of 3, plug it in for the m. Y equals m x, and my b is 0, so I don't have to put plus anything on that.
Why does the 2 on the bottom stay the same?
When we did practical, so we got square root of 3 over 2 is where we're getting this from, divided by 1/2, right? Because we were solving for m, it's being multiplied by 1/2. So when you divide by a fraction, it's the same as multiplying by the reciprocal. So if the 2 times 1, let's say.
Oh, okay.
You knew that, it just brain farted for a second. Yeah. Alright. So that will be planned on Thursday. those of y'all that are not exempt, plan on that on Thursday. So tomorrow and Wednesday, we're not going to do anything. Well, I don't know if we'll be back in here tomorrow or not. I doubt it. I don't know how long. I don't
Which
remember how long.
assembly's tomorrow?
Signing day.
Oh.
I don't remember how long that took last year. I don't know. So anyway, I didn't know if we'd be back, so I didn't plan on doing anything on that. Okay? Starts at 1 is what I was told. I don't know. Might only take 5 minutes now that we don't have anything planned. That's usually my luck, but oh well. Alright? Alright.
Could I go ahead and take my test on Wednesday then?
Yeah.
Okay.